Welcome to iLecture Online, and here's an example where we're going to use Newton's first law to try and understand what happens in an example like this, where a person's riding in an elevator, currently going up at 2 meters per second with an acceleration being equal to 0, meaning at constant speed. And so the first thing we want to try to figure out is what is the net force acting on the person, and secondly, what is the tension in the cable. And so let's say that the mass of the person is equal to m, and the mass of the car that they ride in is equal to big M. So what would be the force on the person? And it turns out the net force on that person is equal to 0. Now I would say, well, wait a minute, how can that be? How can there be no net force on the person and the person be going up? Well, the key here is the understanding that the acceleration is equal to 0. And from Newton's second law, we know that if A is equal to 0, then F net must equal 0. So let's go ahead and try to figure that out. Well, for one thing, we have the weight of the person, which is downward, so that would be the force due to gravity, and that's equal to the mass of the person times acceleration due to gravity, which is downward. And then, of course, since there's a bottom to that elevator car, there's a force pushing back, which is the normal force pushing back, which is equal in magnitude and opposite direction to the weight, so that would be the normal force. And since those two forces are equal in opposite direction, equal in magnitude, opposite direction, they cancel each other out, so there would be no net force on the person acting downward. But then you say, well, that's fine and dandy if the car was not moving. But the elevator is moving upward at 2 meters per second. Doesn't that require additional force? And then you say, no, it doesn't, because Newton's first law tells me that once an object is in motion, so once the person is going upward at 2 meters per second, it requires no force whatsoever to continue going upward at 2 meters per second. So it is true that if the elevator is standing still and then accelerates to 2 meters per second, then extra force is required until the person reaches a speed of 2 meters per second. After the person reaches a speed of 2 meters per second and continues upward at 2 meters per second, the acceleration goes down to 0 and no additional force is required. That's what the first law of Newton tells me, and therefore I know that there's no additional force required to keep the person moving upward at 2 meters per second. So then you say, well, what would be the tension in the cable? Well, what is the cable doing? It's supporting the weight of the person and it's supporting the weight of the elevator car, but it's not adding additional force to accelerate anything because nothing is accelerating. So therefore, the tension in the cable is simply equal to the weight of the person plus the weight of the elevator car, and plus nothing more because there's no additional force required since there's no acceleration in the car. Newton's first law says once the car and the person are moving upward at 2 meters per second, no force is required to continue moving the person upward at 2 meters per second. So the only tension required in the cable is simply to hold up the weight of the person and the weight of the car against gravity. And that's how you use the first law of Newton to figure out how to look at a problem like this.